Hi, everyone. Thank you for joining us for our Ask a Greenhouse Expert webinar series hosted by Ceres Greenhouse Solutions. We're so happy you're able to join us today as we delve into the topic of greenhouse winterization. My name is Haley, and I will be the host / facilitator of today's webinar. Josh and Mark are excited to answer all your winterization questions today. But in order to maximize our time together, I'm going to skip over bios and intros. But if you'd like to learn more about Josh and Mark and their roles and backgrounds, please watch one of our last webinars. I can post a link to our last webinar in the chat. Quick reminder that we invite you all to ask questions at any given point during the webinar, live in the Q&A section. Please keep it relevant or else we might not answer it. Also, this event is being recorded and we will send out a recording to all the participants after, and you'll also be able to access it on our YouTube channel and website. All right, so really quick before we get into it, I'm going to read a quick disclaimer. This information provided during this webinar is for general informational purposes only and is based on the expertise and knowledge of our greenhouse specialists. The advice and recommendations provided are intended to assist attendees in understanding various greenhouse systems. Participants are encouraged to consult with a qualified professional or conduct further research to address any specific concerns or requirements they may have. The hosts and organizers of this webinar are not responsible for any actions taken based on the information presented. All right, so let's get into it. First questions, we're going to go over growing through the winter. And the first question is it possible to grow plants other than lettuce in the winter if I live in Canada? Could a person add grow lights or heaters? I'm going to hand it off.
Well, first of all, hi, Haley. And hello, everybody. Thanks for joining. I think we'll dive into just a quick screen share. Pictures are worth 1,000 words. And we'll show you what these greenhouses look like in the winter. Maybe. Oh. There we go. And well, that should probably be full screen, but it is what it is. This is a client of ours who is in, and we'd call him a partner also, I think, in Ottawa, Canada, where it's cold and snowy.
And he's a jokester.
And he's a jokester. And, you know, the general idea was just like the design intent of our greenhouses is often to function year round with relative consistency throughout the year, summer to winter. And I think we could say winter is often an easier time for our growers than the summer. Greenhouses are hardest to cool and easier to heat, which is a common misconception.
But it's also I'm Mark. Hi, Josh.
Hi. We haven't done this side by side before. So
no,
it's
a new thing. I think it's the greatest time to grow, right? I mean, this is when you have time in the year where we're spending time in a warm, maybe also, you know, people in the west or the mountain areas of the US where it's really dry outside. You go into the greenhouse, and as we'll see some more pictures later, you will see how it can be warm and moist in the greenhouse. It's in a beautiful place to feel like you are transport yourself to your Puerto Rican vacation right in your backyard, including bananas, as in this picture, one of our favorite ones, and guavas, mangoes, what you want to have. You can have all of that in the winter in any place. both in the US as well as Canada. That's not the problem. The one most people think that it's temperature, which is the major limiting factor in growing in a greenhouse in the winter, which is actually not quite true. Um, it's more important for the plants to get enough sunlight or over the day or the average days, and we really need to watch the moisture in the greenhouse, and we'll get into all of those things later. Just to say, don't think a greenhouse and being in a cold place is disqualifying you from growing incredible plants, really any plant you want. It doesn't. Um, you want to probably add a little bit of light and some dehumidification strategies to make sure that greenhouse, the plants will be happy and your pests will be under control.
This is just an example of one of our client greenhouses. This is a custom greenhouse that we partnered with. And this greenhouse was kind of its own ecosystem. It was lightly managed. And it's very cool to see. And we pulled a second photo to show you from the same day that this was midwinter in Colorado. There's snow on the north roof of the greenhouse. This is the backside of the greenhouse. And on the inside, they were growing tomatoes, which is totally possible. And probably you're going to start your tomatoes in the summer, spring, summer, or fall for best success, I think. But they will not just maintain, but they will continue growing and fruiting with appropriate light levels, appropriate temperatures, and hopefully controlled humidity levels. And this greenhouse was also starting to kick out banana bunches, which is pretty fun to see in the middle of winter in Colorado.
Yeah. And it's really, that's not only this greenhouse. In many other people ask about, I want a tropical greenhouse. How hard is it? And the misconception there is really that a tropical greenhouse would be harder to grow than, for example, a tomato greenhouse, which is actually not quite true. The general knowledge is tomatoes are probably the most finicky plant that you can grow in terms of temperature. So any tomato below 50 degrees Fahrenheit or 10 Celsius, it's just not going to be happy, and it doesn't matter what you do. So whereas a banana tree and many other trees, citrus trees, etc., they can all be happy at way lower temperatures and still produce fruit, or bananas in this case. So actually, tomato greenhouses are harder than tropical greenhouses.
That's right. With tropicals, they cannot, and citrus as well, they cannot freeze. You start to see some leaf burn and some other things as you get close to freezing, but not freezing is significantly easier than 55 degrees at a minimum-ish for tomato production. So again, most people who are growing tropicals in our greenhouses or citrus, it's for fun. They're not actually like an orange juice company or anything like that.
No.
We'll get there. But the tomato producers, you're really trying to maintain appropriate temperatures, and that's the hardest part of winter growing. Leafy greens are much easier to grow. They can handle lower temperatures. They can handle lower light levels. And so Rob Lyle is growing lettuce through the winter, no problem. He has supplemental lighting.
Yeah.
But we have other growers who grow through the winter with no supplemental lighting and very minimal heating inputs, which we'll get to.
Yeah. It's winter growing is the most fun, like, because this, for most people, this is the place where you want to be in a greenhouse. This is the best time of the year where you can really show off your amazingly fresh fruit, vegetables to your neighbors and say, look what I have, and something that you just can't buy anywhere else because the tomatoes flown in from Mexico or wherever will never taste the same. They are harvested green, then they put into an ethylene chamber where they get made somewhat reddish. We have a joke in the company sometimes that we just call those vegetables, many of the ones we get in the winter, you know, brightly colored water, but they're not really that good. And if you grow them in the greenhouse, they taste just like they taste out of your own garden in the summer outside.
So you kind of answered this, but maybe just again, is there a noticeable difference in plant quality in the wintertime versus the summertime in a greenhouse? Noticeably.
I think the answer is that it's all relative. And it's how your greenhouse is set up. We have greenhouses that have very well-designed and appropriate heating systems to create 70 degrees in the greenhouse all winter, if that's what's required. If they have the correct shading systems to hold in heat and everything else in the winter, we have minimal temperature fluctuations in the greenhouses throughout the day to night winter temperature changes. So we could be producing really high quality food in the greenhouses all winter if the grower is willing to pay for those inputs. There's a cost to it. That being said, as I said before, we've got growers who are using no inputs, no light, and only our GAHT system, and we'll show that, to grow lettuce. And her argument is her lettuce with no inputs is still higher quality than the lettuce that she can buy that was shipped from Arizona to Wisconsin. So are the greens as good as they would be midsummer? Maybe, or maybe not, but are they better than what you would get otherwise? And I think the answer is definitely. We're still harvesting that morning and people are eating it that evening.
Yeah. I think the biggest thing, really, the biggest difference, because temperature and humidity in a greenhouse can be simulated to be anywhere in the planet anytime, right? It's just a question of how much money are you spending on creating that environment by heating it, etc. Of course, you need to have much fewer inputs when your greenhouse is highly insulated. That's a no-brainer. The one part that you need in most of the northern hemisphere is you need to supplement the light that you're getting from the outside, right? So if you're in some cloudy climate, you have to use supplemental light, and without that, you won't grow all that much. So the plants need the lights to actually make the wonderful flavors and colors that your fruits and vegetables want, and you just need to provide that kind of a light to create that. And if you're able to do that, maybe offsetting it with wind or solar, then it doesn't actually take all that much energy to do and allows you to grow anything you want, or you could have any plant anywhere in the world grown in your backyard, no problem.
Beautifully said. This is a really quick question. What are your thoughts about using mulch around the pots in the greenhouse and outside?
Yeah. Depending on how you're growing, oftentimes we have clients who just grow in the soil, and we have clients who have concrete slabs and then grow on it. Ideally, if you're keeping a potted tree or something in the pot, mulching it's great. Insulation in general is great. Stable root zone temperatures are important. You can also bury a pot into the soil, so keep it potted, but put it in the ground. That's maybe an even better way to get it away from fluctuating air temperatures. And then I think thinking about soil temperature is probably important for those things. The earth is kind of good insulation and a bit of a heat source. And if we're running our ground air heat transfer system and we're putting heat into the ground and we're warming the soil, that further is a further benefit. So there's many levels, but yes, insulating pots in greenhouses, if you're trying to use minimal inputs to maintain soil temperatures and prevent things from getting too cold, is a good idea.
Well, there's insulation, and then there's trying to prevent the soil from evaporating too much water, which is a common problem in greenhouses in general, that in the winter, when the sun is out, the sun can be very, very intense. When the atmosphere has almost no humidity, people don't recognize that the sun intensity that you get in most of the US in the winter months is higher than it ever would be in July. So in February, January and February, you can have the most intense sunshine. And that would heat your greenhouse significantly in the day. It makes the air inside the greenhouse really dry, which just basically means the air is trying to get the moisture from the soil as quickly as it can. It dries out the soil, but it brings all that water into the atmosphere. And then at nighttime, the temperatures go down, and all of a sudden, everything in your greenhouse is completely covered with a water layer, which doesn't allow the plants to breathe. That's one problem. But more importantly, you just start making certain pests really happy, powdery mildew, etc. And you invite a bunch of life into your greenhouse that you really don't want. And so the mulch really helps to prevent some of the evaporation of the water, and therefore keeps your greenhouse at a more moderate humidity level, which your plants really, really appreciate.
The color of the pot is also black, almost always, which further heats and causes that issue. So blocking the sun from directly hitting black plastic and heating further or faster is also a great idea.
Yeah.
Awesome. Next question. What steps are required to prepare for the winter that we would not normally do in the summer? Maybe a vestibule to the exterior doors.
Yeah, we have a few things that we can talk about. And I mean, I think to start, there is both. So our greenhouses, for the most part, we run our SunSense controller, but any greenhouse, hopefully that is somewhat being managed, has some sort of control system. And I think maybe it's important to discuss really quick that as we transition from fall into winter, summer into winter, we're changing the controls strategy of the greenhouse somewhat. I mean, that's step one.
Yeah.
We're now thinking more about primarily heating, but also needing to cool on sunny days, as opposed to straight cooling all the time. Dehumidification becomes more important. What else are we thinking about when we're transitioning?
Lights.
Lighting. And so to the question, I'll screen share again. This is a half example. This is a warmer climate greenhouse in a dry area. But what we see is people trying to create space if you don't have a head house or a separate entry zone, instead of walking directly into the greenhouse. This is rather large, but oftentimes people build a smaller version of this, but with walls. So you have a accessory room from the exterior that you enter, and it creates basically a buffer zone where you can potentially change clothes, dip your shoes in a foot bath, whatever it is, but also buffer the air so that you're not walking in, if it's 0 degrees outside, directly into your greenhouse. The greenhouse can handle it for the most part if you walk directly in. The smaller it is, the more effect it would have. It's not a huge deal, but the more we can minimize it, the more stable the environment in the greenhouse will be, which is usually beneficial.
Yeah. And I mean, it's, we have plenty of clients where the outside temperatures dip to minus 30 degrees. At that point, it doesn't make a difference between Fahrenheit and Celsius. But so at that point, you open the door, you get the really cold air coming in, and you want to be careful with all of those venting strategies that you still may need in the winter time to be gentle to the plants. So you need to have some mixing strategy, and having a vestibule, having a different entrance door, like a double entrance, airlock situation, depending on where you are, can be really, really helpful.
And so this is something that it is November. It is mid to late November right now. And this is what some of our clients are doing right now. So in the summer, these are intake louvers, which are normally on the west side of the greenhouse. And in the summer, we need them all because it's full airflow. There's a vented greenhouse and we need everything. In the winter, did I say in the summer we need all that?
Yeah.
In the winter, we don't need all that. We'll never go full exhaust because it's cold outside. And that would freeze the greenhouse or make it too cold. But we do need some. This greenhouse is in Denver, Colorado. It's sunny. It can get quite hot in the greenhouse in the middle of the winter. And so what you'll see here is 3 of these intake louvers are very well insulated. It looks amazing. But one is not. That upper one is still not insulated. It's also on its own circuit, so it can be controlled by itself. So the 3 that are insulated are basically off for the winter. So they're not opening and closing behind the insulation. They're just off. And we've switched modes so that we're just intaking lower CFM. So we use a smaller fan when we exhaust, and we only need the single intake louver to allow in the appropriate amount of air without creating a pressure situation that would negatively affect the exhaust fan.
I think for most people, the really fun thing, you will look at your own greenhouse if you already have one. You know, there are rather inexpensive louvers that are leaky, and when there's the slightest amount of wind, they start flopping, and then you let really, really cold air come in. And if your plants are very close to close to those louvers, you will literally freeze them, and it's really, really unfortunate. So I believe most greenhouses, as a winterization step, is really this insulation, which you can put on the inside, you can put on the outside with bungee cords. I've seen all of that. I have seen people make very, very fancy sliding louvers from, you know, their favorite carpenter. There are many ways to do this, but it is the single most important thing that you can do is prevent, in the cold nights, prevent your warm air from the greenhouse to just leave the building. That's just never a good idea.
Okay,
So
I think I'm going to be a little unconventional here.
Okay.
And I'm going to grab some props.
Okay. And by the way, there are different louvers in different qualities. Some of them are just very, very non-insulated in aluminum, which itself is very conductive. It goes to very highly insulated louvers as well.
I realize this isn't the most ideal, but the general idea is this is a cheaper standard louver, and it is non-powered. And so if I tilt it, they just open. And when the wind blows, kind of does that. And in the winter, that means cold air is coming in potentially when you don't want it to.
By the way, can people see that, or is that from are we still looking at?
Haley.
I believe people can see both.
Okay.
Yeah, but I'll stop sharing. So this is an upgraded louver that we're using more and more. When I tilt this forward, they don't open. And when we look on the back, we have a Belimo motor, which is a pretty robust motor, but we also have insulation at every spot where the fins open. So when this is closed, it's really closed. And we found that this makes a really huge difference in winter operation of the greenhouses.
And if you have even more, if we want to be even more prepared for the winter, you can have each one of these louvers by themselves being insulated. So they are actually having foam in between the aluminum pieces, which make them even better. So there are many solutions to this problem, which is one of the biggest, is how to keep the cold air from coming in the winter months. That's the biggest thing that you need to look out for.
Great. Thank you for that prop demonstration.
That was fun. It's good to stand up every once in a while.
We're going to get into a pretty important topic when it comes to greenhouse winterization, and that's heating. First question is, what is the most efficient way to heat a Ceres or non-Ceres greenhouse during the winter months?
My favorite topic. I'll
So-
start with it.
Yeah, yeah.
So heating, most people have some kind of a gas heater, which is the most standard thing to do. It can be propane, it could be natural gas. That's the standard for many commercial greenhouses. And those are obviously not climate neutral. And so what other ways are there to heat the greenhouse? And there are many, many, and we can talk about some of those today. The easiest one that we already talked about that we use is the GAHT system.
Yeah, I think before we dive into GAHT,
Okay.
I think it's important to say, if you're on a natural gas line at your property or your business or whatever, it's a very cheap way and relatively easy way, and they burn pretty efficient way to heat a greenhouse. It's standard.
Yeah.
So monthly expense wise, for active heating, it's your cheapest bet. Now, there's other implications there that it has to be drilled, all the things, but that's baseline. For all of our clients who don't have natural gas, we can basically use the same heaters, but with propane. It's a slight conversion. Still fairly efficient, but now you're paying a lot more
Per BTU.
per BTU because
kilowatt hour.
propane is more expensive than natural gas. So operationally, it's the same. Your operational expenses are slightly higher. But we often get into how do we do this without using those standard heating technologies, which is what we're going to dive into here. And so at a minimum baseline, the Ceres GAHT system, ground air heat transfer system, which is a climate battery, is a baseline effective winter heater, depending on what your heating needs are. So we can talk about that.
Yeah. And I think, it's your basically, instead of burning natural resources, you use electricity basically, which is you can of course do with electric heater as well. But the GAHT system has the wonderful thing that it will take the warm air that you're getting in the winter months inside the greenhouse, to take that warm air from the top of the greenhouse, put it down into the soil, you heat the soil and in the daytime, and therefore cool the greenhouse, which basically says I have excess energy in the greenhouse in the daytime. Instead of venting it out because the temperatures get too high, we just pump it in the soil and try to heat the soil, which makes the plants happy. And so that's a great way to go about that. And then in the nighttime, you take the cool air. Well, you can show the next one if it really, really wants to come.
Well, it went to slideshow and now it's trying to just roll through it.
Okay. So here you can see a greenhouse that is also here in Denver, but it happened. You can see that the GAHT system running in the daytime can keep the temperatures at about 55 degrees without any heating. So the outside was below 30. We went down to 24 degrees that night. And the GAHT system alone just kept the greenhouse at lovely 55 degrees because it's a tomato greenhouse, so they doesn't want to get close to 50. So he has heaters that he could run, but he is very interested, the client is very interested to being as climate neutral as possible. So he just runs the GAHT system. The GAHT system keeps the greenhouse at 55 degrees in the nighttime. And then in the daytime, because he has a lot of warm plants, he is okay with about 85 degrees. So the greenhouse stays really within 2-3 degrees of around 80 to 85. And that's the time when the GAHT system is definitely heating again for the next night. And so we have had many cold nights in a row now, but also sunny days. And in all of those days, the general rule is, if it's sunny, the sun that you are having in the daytime is enough energy, provides enough energy to heat you all the way through the night. And that's a really, really cool way. All you need is the electricity for the fans.
So this greenhouse in particular, what you're seeing is this is a one GAHT fan, and there's a second GAHT fan here. These are the two intakes for the whole greenhouse. This is a 30-foot by 60-foot greenhouse. And she grows commercially lettuce all winter, and this is her heat source.
That's the only one. And we have many clients
when it gets really cold, she said -20 for over 3 days with no sun. She has a heater that she'll use, but for the most part, this is it.
Yeah.
And this is in Wisconsin, which doesn't have a big solar recharge during the day.
Right.
It's not an ideal GAHT location like Colorado might be because we have sunny days. And she's able to grow lettuce through the winter, which is really so minimal inputs, 2 fans.
Well, we had other greenhouses here in Longmont where we had bananas all the way through with 0 heaters.
Yep.
So this system will keep it always above freezing, which is good enough for most places.
Yep.
But I do, as being a solar nerd, love the idea of being able to heat the greenhouse with solar thermal, meaning you have solar panels that don't make PV as an electric as much, even though these power panels are a new thing that are just here. So they basically make electricity and hot water at the same time. And so one of the greenhouses that you saw before with the bananas, they actually have 4 solar thermal panels, meaning hot water panels, on the roof that heat a small tank. And from the small tank, the water goes into the soil, heating the soil. And so they can grow those bananas just on 4 panels on a 30 by 100 greenhouse. And it is amazing. And it takes very, very little energy. So if you have the possibility to grow, if you don't want to use any or almost no electricity, a solar thermal panel is just fabulous.
So let's just back up a second. Pumping, water holds heat better than air.
Yep.
Pumping water is a very efficient way to move
heat.
Things like heat or coolness, as opposed to a fan that blows air.
Yeah.
And so if you're designing a low energy heat system, water is actually ideal.
Yeah, better than air.
Better than air. But the upfront costs are usually more expensive because we're now talking about piping and some other things. And you have some more opportunities for failure with leakage and some other things like that. The GAHT system is 2 fans and some PVC, ABS,
HDPE.
Marc's a chemical engineer. HDPE piping, and it's perforated underground. So it's already got holes in it when you buy it. And so the only thing that can really fail in a GAHT system's climate battery is the fan. And the fan is
they don't fail
at 4 feet off the ground, right in your face, easy to deal with if you had to deal with it.
Yeah, and we use really good fans. Those don't seem to fail. That's so over decades, we have not seen them fail. So that's a really cool thing.
Okay, so we'll go back to the power panel real quick. This is a new partner that we're just starting to work with, but we're just trying to show you a concept, which is, this is a unit that you could just land next to your greenhouse. And it can produce some power, maybe not enough for your greenhouse, maybe enough, depends what you want to do, but it also creates hot water. And this hot water could then be integrated into a low energy input greenhouse heating system, which is a pretty fun thing to think about. And it's fun for us to work on. A few other alternatives for heat, because we get this all the time.
Nuclear power plant. No, just kidding.
Anything that is local can be, whatever is commonly available locally to your location can be a resource. We have a lot of forests in the mountains. So you can burn a wood stove in the greenhouse, but that is a lot of effort. And a wood stove doesn't burn all night unless you're feeding it. So you might actively be very involved in your greenhouse at that point. But we've had other clients who use pellets, and this was a 4 greenhouse complex with a head house. So they had 5 pellet stoves. This is actually a hopper, and then it fed the pellet stove, and this burned pellets and heated the greenhouse for many winters.
Yeah, and that's natural.
And here it's slightly processed, but it's basically a byproduct. It's a sawdust product that's compressed into pellets. And before they started growing, this was their greenhouse with their pellet stove.
Yeah, and I think you can consider that climate neutral, right? Because it's the CO2 that's gotten off the wood is in the whole site is climate neutral.
So this was cool. They had light deprivation in this greenhouse. We modified their light deprivation system to deal with this exhaust trunk that was coming down. But this was a pretty cool way to heat the greenhouse. A little bit harder, more maintenance than gas that just is clean and shows up and it's magic, but way more sustainable.
Haley, are we talking too much?
No, you're talking just the right amount. Are you ready for the next question?
Sure.
So similar vein, but someone was wanting to know specifically about fuel costs and cost to products. And I'm wondering if you have some examples or can have a few, cost examples of heating.
I didn't, because this is the kind of math that I don't do, but we have people at Ceres who do this kind of math. I asked Hervé, who's one of our engineers, about a 3,000 square foot greenhouse, which is a fairly standard size greenhouse for us, 30 foot by 100 foot.
Wait, 10 meters by 30 meters.
10 meters by 30 meters. If this is going international.
Yeah.
Okay. And 2 locations and different fuel sources. We picked 68-degree set point for heating. This is a heating conversation.
That's roughly 20 degrees Celsius.
Thank you, Marc. Marc is not only very smart, but he is my international.
Not everybody is American.
He's my metric. What are you? You translator. My metric translator. So it's 3,000 square foot greenhouse in Boulder, Colorado. That's where we are. And then I did another one we did another one in Ontario, Canada as well. So we get 2 different ideas. With natural gas costing $1 per therm. Gas is measured in therms. You'll see it on your bill. I think it calls out therms. 68-degree Fahrenheit set point, $1,700 a year in a Ceres greenhouse to heat the greenhouse. Now, our greenhouses are insulated on the north wall, north roof, east wall, west wall, usually some sort of efficient glazing. A conventional greenhouse, which is full poly or glass or something like that, would cost $4,200. So $1,700 versus $4,200 for natural gas. So it's not quite a third, not quite half. We're kind of right in the middle of that zone, but you can see in a Ceres greenhouse, $1,700 a year heating costs. It makes sense to grow through the winter, especially if you're a 3,000 square foot greenhouse, which is usually a commercial greenhouse. At 68 degrees, you're growing tomatoes at that point, and like really growing tomatoes.
Well, and then we haven't talked about there's always the issue about heating, as if that's living in a net zero energy house, which I'm very happy that I was able to do that. The biggest thing is insulation before you use natural resources to heat. And so the insulation is the biggest issue. And in greenhouses, there are now amazing materials and that can be used as temporary insulation.
We're gonna get there.
We're gonna get there. It's like, oh, this is the end part of this conversation. I'm looking forward to it.
So I was just gonna go one other example is in Ontario, if we're trying to keep that 68-degree set point. And it's a little bit funny how we did this, but now we went to propane. So let's say this is a rural greenhouse in Ontario at $2.2 per gallon of propane, because now you're paying per gallon. The Ceres greenhouse costs $5,600 a year to heat, which is significantly more because propane is significantly more expensive than natural gas. The conventional greenhouse is at over $15,000 a year to keep it 68 degrees. So you can start to see how the building envelope matters, the fuel source matters, the cost of the fuel, and your location. Ontario is going to be colder than Colorado, and so you're going to be paying more for that as well. So that is a totally random example of heating costs, but hopefully it's somewhat helpful to give you a feel of what it might look like to heat a greenhouse.
Awesome. Really quick, we had a question in the chat here from Tatiana asking about wood gasification systems that run in radiant pipes in the greenhouse. Do either of you have any experience with that source of heat source?
Like a wood boiler potentially? Wood gasification? Is that what you said, Haley? Wood gasification?
Wood gasification system that runs in radiant pipes in the greenhouse.
So like what I don't know about the gasification part. I do know about like exterior boilers that you can run outside of a building. That's a wood stove.
It's not
the
that's
same.
a different thing. That's altogether. It's a different technology that we really not really. I don't know that we have the knowledge that to really answer that. I know it exists and it's a possibility and all of that, but no, it's I think there are technologies you can buy for that. And it's more involved. Let's just keep it at that.
But
Let's
you
not talk about stuff that.
But you could get an exterior wood boiler, which is a simpler system.
Yes.
Which is a hot water system. So
Yes.
you're burning a wood stove in an outside little building, looks like an outhouse almost.
Yeah.
You're feeding it. It's very efficient, so it
Yeah.
will burn all night. It makes hot water. That hot water can come in the greenhouse. You are now heating your greenhouse with hot water from wood.
And you can heat the greenhouse, either the soil in the greenhouse, or you can have fluid coolers, or
some kind of heat exchange.
Some heat exchange devices that are basically it's a radiator with a fan behind it that blows air through the radiator, and the warm water from your combustion source allows you to actually heat the greenhouse very efficiently. And the nice things about big boilers always is that they last a long time, so they can run all the way through the night versus taking little rocket fuel ovens, which we have some clients to do that. They need to feed that every 2 hours. Not so much fun at night.
Rocket mass heaters.
Yeah. Yes, that's what they call it, right?
You said rocket fuel.
Oh, okay.
Which I love.
Okay.
We don't actually burn rocket fuel to heat our greenhouses.
Next question for those growers that live in snowy regions during the winter. How warm do you need to keep your greenhouse to keep snow off the roof?
I can take that for now. So the easiest to say, there is in the International Building Code, IBC, is a section about how you calculate the roof snow load for snow. In fact, that's the part that you're trying to do. And you can deduct 15% of the roof snow load if your greenhouse stays above 50 degrees all winter long. So in other words, your greenhouse is at 50 degrees. The snow will just slide down the roof. Now, if you have a greenhouse like ours, that's a no-brainer. It will be doing that by less than 50 degrees. There is no snow on that roof. That is significant. It just doesn't happen because the greenhouse is always warm enough that it will just slide off. This is a little trickier when you have a Venlo style, or where you have multiple greenhouses next to each other, where you have a gutter connected greenhouse, which has valleys in between each of the roof gables, and then you actually you're collecting the snow, and that's a different problem. And you can get ice dams and all of that. But let's say in most cases, the snow comes off. If you are at 40 degrees inside the greenhouse, that's okay for most greenhouses. if you want the official answer, look it up in the IBC code, and you'll find 50 degrees. And at 50 degrees inside, it definitely is going to come off on the the outside.
And we can say anecdotally, our standard greenhouse kit is a 312 roof pitch on the south face, which is the glazed face of the roof.
Yeah.
When it snows, I've been in these greenhouses during the day. I've been in these greenhouses at night. If it snows a few inches, that snow is moving. The minute the sun comes out in the morning, that snow is moving.
Yeah.
And so they don't accumulate. I've never seen a foot of snow on the south face of one of our greenhouses. It exits. We also always leave a 2-foot knee wall at the bottom of our south wall, the vertical wall, just for that purpose. Snow is coming off the roof of our buildings. It will pile up, and it's something that needs to be managed. But instead of it being against glazing, which creates a cold glazing spot and then condensation on the inside, all these things, we use our insulated metal panels for the first 2 feet of the wall to really thermally break that cold snow pile from the inside of the greenhouse.
Yeah. And in general, I think the one part where this may not quite apply, and I've heard that from some Canadian clients that have this freezing rain issue, that weather is changing, and all of a sudden you have kind of rain that falls on very cold surfaces, and you're really starting to freeze on the surface. That can happen in extreme cases. But then again, most of the greenhouse glazing materials are not that highly insulated that will not relatively quickly just slide off.
Excellent answer. I'm going to move on to insulation just to make sure we get to answer questions from each section.
Yeah.
Is there a heat reflecting curtain to help maintain heat?
Haley, if you don't mind, I think what I'd like to do is just quickly zip through the humidification and dehumidification really fast, just so we can be done with that. But I think it's worth everyone seeing. In the winter, this is a winter conversation. This is a fogging system, and sorry, it's a video, but you can see this is a fogging system on. We use this often in our greenhouses. This is a cooling system for the summer, but it's also, you can add humidity in the winter. We're not really using this very much in the winter.
Well, it's just when you have really cold outside conditions, your greenhouse humidity level can drop to below 20%, and then your plants are constantly stressed. So the humidification function of a fogging system is super helpful. A wet wall, which is also used for cooling, cannot really be used in the middle of the winter. Right. A fogging system can. And so the beautiful thing about fogging systems is they can keep your plants in the happy zone, which in most places is somewhere between 50 and 70% RH. And so the relative humidity in that range, plants are really happy. And especially younger plants. So the only way to do that consistently is really using a fogging system.
And the flip side of that, again, we could probably do a whole webinar on this, but the flip side of that is the minute it cools down at night in the winter, the air is going to shed water. It can't hold as much moisture.
Right.
And so now you have to get rid of that. So we try and find a balance between using that fogging system as little as possible, but to maintain healthy plants and keep plants in a healthy vapor pressure deficit. But then you got to pull water out at night.
Yeah.
And there's several ways to do that. This is just a dehumidifier that's on the north wall. That's the same GAHT system, dehumidifier. This uses power. A byproduct is heat. So it's actually a heater. It helps to heat in the winter, as not necessarily intentionally, but it does. The other strategy we're doing right now is small vent fans. It's dry outside everywhere, mostly in the winter when it's cold enough. And we'll just move a little bit of air out of the greenhouse, which means we pull in a little bit of dry air from outside the greenhouse. And that's a more efficient way
you leave
to now we have to heat more.
Right. Now you need to heat more.
But it's often a lower cost way to just exhaust a teeny bit of air, constantly have a little bit of dry air coming through the greenhouse.
Yeah.
Okay.
And it works really well. I mean, both of them work very well. Both of them take a little bit of energy, but controlling humidity is an absolute must because plants are not happy when they're
Too dry or too wet.
too wet, dry, or too wet.
Okay. So now this is the fun stuff. Marc's going to talk for an hour.
Oh, no. Yeah.
But really quick, this is a
We have 10 minutes, just time alert.
This is what we would traditionally call a shade curtain, but it's actually an energy curtain, just the same. You can install these like you're seeing here, automated, where our controller will open it or close it depending on certain conditions. Or some people just have fixed shade cloths that they put either on the outside of the greenhouse or hang on the inside of the greenhouse all summer. This is a very effective tool for us. It is basically, I don't want to say no power, but very low power. It's only using power when it opens and closes, and then it's sitting dormant for hours while it's shading or not.
Right.
So in the summer, this cools, but because this is a winter thing, this is, I mean, they say, and I'm not sure how the math happens, but it's 47% heat retention.
Well, if you take, I mean, there are shade cloths, depending on what you want. There are shade cloths that can go to 75 and
Sure.
80% reduction of heating needs.
Right. This is dual purpose. So this is shade. We use the same fabric summer and winter. So it's kind of, it does both. So it's not amazing at either.
Mm-hmm.
But something as simple as this, the glazing is the spot where you lose the most heat in the building. Our whole greenhouse is insulated except the glazing.
Yep.
This is like a little bit of a blanket at night.
Yeah. And you can do a double blanket if you want.
And you can do a double blanket, but this reduces temperature swings in the greenhouse.
Yeah.
So there's plant health to think about. There's operational costs to think about. Significantly can reduce your heating costs. We are designing these into almost every greenhouse that we do now, whether it's residential or commercial, to keep greenhouses cool in the summer and to keep them warmer in the winter.
Yeah.
Now that super fun stuff. This is a closed shade system. This is Omaha, Nebraska. It's the middle of the summer. It's just in shade mode.
Yeah.
All day. Now here's the fun stuff.
Oh, the fun stuff.
So in this greenhouse, what you'll see up high is a shade curtain, and this is called a flat slope style is the design. So this is a shade and energy curtain, and you can, I don't know if you guys can see it, but there's a lot of aluminum strips in this. This is really more of an energy curtain than a shade curtain. It's just a ratio of transmittent fabric to not reflective fabric. But the most fun part and the really exciting part is this bit down here, which is also a retractable, movable system, just the same. It opens and closes, but it is.
It has infrared reflecting properties. So in other words,
well, you have to say what the fabric is.
The fabric is ETFE, which lasts forever. It's very, very thin, only about 25 microns. That's tiny. That's the size of your hair.
Your hair?
No, mine. Thinner than your beard hair, I think. Anyway, and it has a coating on it, and that coating allows for the infrared radiation to reflect, which means, in one hand, it doesn't let the heat come in from the outside. It basically hits that fabric and then reflects back out. And on the other side, when it's closed in the winter at nighttime, the heat coming from the plants make it to the fabric and get reflected back. So you're significantly reducing the heat loss in the winter. And it's an awesome material. It is brand new. Kind of in a beta phase, so we're just employing it. On this picture, it looks like there's this darkness underneath. You can't. It's not a great picture for how clear it actually is. That material is basically clear, and you see these little hooks on which they run. So we employing these now with the first greenhouses, and we believe that's a game changer for the whole industry. It will be, because this is amazing and it will last forever. So
And the idea here of it moving, and we'll wrap this up here, I think, but when we're working in some projects in really hot places in the Middle East. In those places, we might use this infrared blocking film as the actual glazing of the greenhouse, which means we're always rejecting the infrared, which is heat. But for winter moments, we want the sun to be warm in our greenhouse during the day. And if this is deployed, nothing's getting warm below the ETFE. So during the day, this is open and we're letting full sun into the building. It's all warm. It feels good. Everyone's happy. And we can run our GAHT system and do all the things. But in the summer, we can close it and still let the light through, but reflect the heat and keep the greenhouse cooler. And in the winter, when we close it, it gives us a layer. So it's just insulation a little bit.
Yep.
But then, as Marc said, it knocks any heat coming from the ground. If you have a slab or something, it keeps it down in plant level and doesn't let it escape through the building.
Someone's
So that's
wondering,
it's very exciting and new.
Murray is wondering if it can snag and tear, or how easy that is.
ETFE doesn't tear. So none of these systems are designed to move, and we design, the whole building is integrated. So we do clash detection for everything. These things move across the whole ceiling. And so when we design everything, it's designed so that nothing is getting in the way of these moving systems.
Great. Really quick, because we have 4 minutes. We did talk about the GAHT. So if you want to talk about more about the GAHT really quick, or we could just go to lighting and
here's a GAHT exhaust in a happy nasturtium corner. And we can leave it at that.
Okay.
I think we should talk about lighting, because let's
really
just
quick.
do it very quickly. So lighting is a little tricky, only in the sense that there's really wonderful LED lights and they are efficient in all of it. I think the trick with them is if you just have them on and off, then you're using much more energy even with LEDs than you would otherwise. It's really nice to have a smart controller that basically measures how much light the plants get during the daytime already from the sun, and they just augment to get to the light levels that the plants need. So it will say, oh, today I got 50% of whatever the plant needs. I need to add another 50%. And if they're halfway smart, they can even look at the weather forecast and say, okay, today is the upcoming day is going to be cloudy. So today we're going to need more light. But the nice thing is, on a sunny day, you don't use any light, because then your greenhouse is just happy, right? And so that's where a smart controller comes in really handily, because it will reduce the amount of heat or the amount of light that you need, and therefore make your greenhouse much more sustainable, which is what most people usually look for.
And we tend to design, now this is more for commercial clients, but we tend to design for worst case scenario. So really the darkest day in the middle of the winter, and we'll take whatever available light is on that cloudy day, shortest day, and we will design a full lighting system to supplement that back to whatever the grower's minimum is. So there's a major initial cost usually to a full lighting system. But the way we do it is that you're hopefully using it very little, but it's there as a baseline. So you can always do that thing, especially if you're growing tomatoes in the winter or something like that. And for a lot of our residential growers, they might just throw in a few in a random spot where they keep tomatoes.
Yes.
But the idea is, if you really want to do the thing, grow tomatoes all winter, this is something that you have to think about. Not this photo, obviously. This is a high-end commercial greenhouse, but appropriate lighting to achieve the goals that you're setting out to do. There was another question about light as heat, and I'll just say real quick, these LEDs are very efficient. They do put out a little bit of heat, but they're not heaters.
No.
Old lights, high pressure sodium lights, which are bulbs, metal halide lights, which are bulbs, they could be heaters. If you needed heat in your greenhouse, you might turn on your light at that point, because they're inefficient, which means they're putting off a lot of heat. But LED lighting is getting more and more efficient, which means it's less and less of a heater with every bit of efficiency that it gains.
And it doesn't, I mean, using light bulbs at heaters doesn't really help it, because your plants will not want, all night long. They want light for maybe 12 hours, maybe maximum 16 hours. So you're going to be 8 hours at night where
You need other heat.
you need other heat anyway.
That's right.
Great. Thank you so much. That was a lot of great information covered. I know we covered a lot and maybe rushed through some things. So I wanted to put the screen up for contact information. If you have any further questions or have a project specific question, please email us at info@ceresgs.com. We also offer consulting packages. So if you're interested in that, please be sure to inquire. Thanks so much, Josh and Marc, for answering everyone's questions. I'll be sending out a recording of the webinar afterwards. We'd love to hear feedback too. So if you have any ideas for future topics you'd like to know more about, please feel free to email us back or reach out. And we look forward to doing more of these in the new year. So thank you, everyone. Thank you, Josh and Marc.
Thanks, Haley. Thanks,
Thank
everybody.
you.
Stay warm. Keep your plants warm.